All right, guys, let's go ahead and go over this iStep prep number 3. In a protected wetland, the number of native reed plants has decreased. They are being taken over by a non-native weed called purple loosestrife. A biologist decides to pull the purple loosestrife from the protected wetland. She predicts that the number of purple loosestrife, as they decrease, the number of reed grass will increase, improving the habitat. The results are shown in the line graph below. All right, so what we're talking about here is an invasive species. An invasive species. And what that does to the ecosystem, okay? Alrighty, so what we need to do here is we need to take a look at this graph and then the key. All right, so we have the solid is going to be our purple loosestrife, and then the reed grass is going to be the dotted here, okay? Alrighty. So over time, so this is a line graph, so over time it appears that the purple loosestrife its numbers has decreased down to 0. So that's a good thing. Compare the results shown in the graph with the prediction made by the biologist. Be sure to explain in your answer why the biologist's prediction should be accepted or rejected. Well, if we look at what her prediction was that as the number of purple loosestrife decreases, the number of reed grass will increase. And that is exactly what happens here. The biologist's prediction should be accepted. The purple loosestrife numbers have decreased and the reed grass is increasing. The biologist noticed that the population of ducks living in the wetland decreased along with the reed grass population. The ducks build their nests in the reed grass. So here what we're looking for is loss of habitat and how that is going to affect a species. Use the information in the graph to predict how the duck population will most likely be affected as a result of the biologist removing purple loosestrife from the wetland. The duck population should improve in the area because their habitat is improving. Ducks build their nests in the reed grass, and there is more reed grass. So as the ecosystem returns to more normal and we get rid of this invasive species, then the population of other organisms in that area are going to return to normal, the ducks being one of them, because their habitat, where they are going to build their home, is now present in that environment. What force does the moon put forth that causes tides on Earth? That's a gravitational force. Describe how the tides would be affected if the moon was larger and had more mass. Well, if the moon was larger, it's going to have a stronger gravitational pull. So if the moon has more mass, then its gravitational force would be greater, causing higher high tides and lower low tides. Explain why the moon remains in orbit around Earth and does not move out into the solar system. Well, we know that the two forces that keep an object in orbit around another object in our solar system are inertia, which is moving in a straight line, and Earth and gravitational pull, gravity, which keeps that object in an orbit or in a tug around the larger object. So inertia and Earth's gravitational pull keep the moon in orbit around Earth. The students measure the mass of an open beaker of water and find it to be 452 grams. All right, so our beaker is just going to be something like this, right? And so they measure the water, and it's 452 grams. The students heat the beaker on a hot plate and allow the water to boil for 10 minutes. After the beaker cools, the students find the mass of the beaker of water to be 439. All right, so after we have had a time to boil and we have all of this water vapor occurring, now it is 439 grams. Should probably have that a little bit lower, right? And it's asking, well, why? Well, why? Some of the water turned into water vapor and evaporated when the water boiled. So it just went out into the room, out into the atmosphere. Predict how the results will be different if the student repeats the experiment using a closed beaker. All right, so we have got this same beaker, 452 grams, except this time we're going to put a lid on it. Okay, so they are still going to put that on a hot plate and boil it for 10 minutes. But all of the water here is going to be trapped inside. So they're still going to be boiling. We're still going to be changing back to water vapor, but it's going to be trapped. So when this is taken off and allowed to cool, this is just going to drop back into here, and we've not lost any of the water vapor to the environment. Oops. Okay. All right, so the mass of the water would remain the same since none of the water would be able to escape through the open beaker. The starting mass and the final mass would both be 452 grams because it is a closed system. When you have a closed system, everything is contained within that. None of it is allowed to escape. All right, a food web. Okay, an ocean food web is shown below. Which organism in the food web provides energy to all the other organisms in the food web? All right, so we know that that is going to be a producer. Don't be tempted to say that the sun is the organism, because the sun is not an organism. So the sun is not an organism. So it is the source of energy for the producer, but it's not going to be what gives energy to all the other organisms in the food web. So in this case, it's the plankton, is the plant product. This is the producer, makes its own energy using the sun to make its own food, and then stores the rest, and then other organisms eat it. Classify the shrimp as a producer or a consumer and explain your choice based on evidence from the food web. All right, so this time we're looking here at the shrimp. Well, does it make its own food, or does it need to obtain its energy by eating other organisms? Well, I see here that I have this arrow. Now, this arrow indicates flow of energy. So the energy from the plankton, stored in the plankton, flows to the shrimp when the shrimp eats that plankton. So the shrimp is a consumer because it does not make its own food. The shrimp needs to eat the plankton to obtain energy. Plankton is a producer, and the producer makes its own food. Everything else, everything that does not make its own food, is a consumer. Use the evidence from the food web to explain the relationship between the heron and the seal. All right, so let's take a look at that. So we are looking here and here. Well, they don't have a direct relationship. There is no arrow connecting these two directly. But if we look at things, we see that they share certain foods, all right? They like to eat the same types of food. So they both get their energy from eating the small fish and the salmon. All right, so what does that mean for their relationship? The heron and the seal are in competition for the same food, the salmon and the small fish. Use the evidence from the food web to explain the relationship between the salmon and the stonefly larva. All right, so let's take a look at this one. So this time we are looking at this relationship here. Looking at the stonefly larva and the salmon. There is a direct between these two. And so the energy from the stonefly larva flows to the flow of energy to the salmon when the salmon eats it. So that is predator-prey. The relationship between the salmon and the stonefly larva is predator-prey. The salmon, the predator, actively hunts and kills the stonefly larva. So it is going to eat this. Okay, so it's going to actively hunt and eat the prey. So this relationship here is predator-prey. All right, and that looks like it's it. So bottom line with this is that a food web is going to show many feeding relationships within an ecosystem. So we could back up and we could see that here is one food chain: plankton, stone fly larva, small fish, seal. All right, so that's one. And we also have others. We could go plankton, shrimp, salmon, seal. That's another food chain. And let's do one more. So we could go plankton, mussel, crab. That's a small one. So in this food web here, it does not look like the crab has any predators. But in actuality, it would, right? Because organisms have can be both a predator and a prey. So clearly something in this ocean web is going to eat, or this ocean environment is going to eat this crab. So what is missing from this would be some type of decomposer. All right, so we would have a decomposer who would break down the remains of all of these organisms and return the nutrients to the soil. Okay. All righty. So reach out if you need anything. Take care now.